Good morning. All right. So, plan for today, we're just going to go through the practice test and let you ask questions if you have any. Again, don't forget, this is due by next Monday at midnight. So, the test has been posted. It was posted yesterday. So, you got about a week to get that done. Let me know if you have any questions about that, have any issues posting it, anything like that, and we'll work through those. But any questions about anything before we get started today? All right. So let's just go ahead and start with the first question here on the practice test. So it says we want to find the present value of $100,000 if interest is paid at a rate of 8% per year, compounded monthly 5 years. And then in parentheses says this means to find the initial investment that produces a desired sum of $100,000. So in this case, which formula are we going to have to use? Let's start there. All right, good. It's our compound interest formula. And notice here, right, we're compounding it monthly, which means we're going to use the one that has the n value, not the one that has the p times e to the rt. Okay, so just make sure we're not doing continuously compounding. We're doing monthly compounding, so we have to use the a of t equals p times 1 plus r divided by n to the nt power. That's the one we're going to use. Now let's think about what values we have this time. So we have the $100,000. Where does that go? Okay, so in this case, though, right, it says we want to find the initial investment that produces a desired sum of $100,000. Okay, so that's right. So A of T in this case is going to be the $100,000 because that's how much we want to end up with. What are we actually trying to solve for this time? We're solving for P because we want to find the initial investment, which is the principal, right? So it's going to be 100,000 equals P times, and then we have our 1 plus. What's our R value going to be this time? Okay, it's good. So we can put that percent to a decimal, so 0.08 divided by N. Well, what's our N value going to be? Good. Since we're compounding monthly, that means 12 times per year, so our N value is 12. And then we use that same N value in the exponent times, what's our T value going to be? Good. So 5 years, so T is 5. Any questions just on getting everything into the formula? Okay, so now we've got to solve for P. So what do you want to do first to solve for P here? Okay, so we can go ahead and do the exponent, the 12 times 5. Good. So that's going to give us 60 as our exponent. And we can go ahead and divide the 0.08 by 12 if you want to. All right, so what's that going to give us if we do 0.08 divided by 12? Yeah, and so this is going to be 1 plus that decimal there, so it's 1.00, and then a repeating 6, right, after those two zeros. This is all still equal to 100,000. Okay, so then what can we do after that? Okay, so we can raise what's in parentheses to the 60th power. Good, so that's going to give us 100,000 equals P times, so if we do that to the 60th power, and so what does that give us? And if we round it up to 4 decimal places, we should be fine. If you want to keep more decimals, that'll give you a more accurate answer. But as long as you show me your work here, I'll be fine with that. Okay, so 1.4898. And then if we kept everything here, it's like 574,571. 8984571. Okay. And again, like I said, as long as you keep at least 4 decimal places there, you should be fine. Then our last step is going to be to do what? Okay, good. So we have to divide by that decimal that we just got there. And once we do that, what do we get? Okay, good. So $67,121. And then in this case, because we're talking about principal, we're talking about an amount of money. Remember, we always want to round to 2 decimal places because that would be the nearest cent. And so that would round to 0.4. And then since we're talking about money, just make sure you put the $sign on that. Again, always go back and think about the context of the problem. Make sure your answer makes sense. So we're asking how much money would we need to invest to end up with $100,000 after 5 years? This amount is lower than $100,000, right? So that does make sense. That's how much we would need to invest. And then after the interest compounds, then we would end up with $100,000 after those 5 years. Okay. Any questions on that one? All right. Let's look at number 2. All right, so we have 2 accounts here. Account A pays 2.5% APR compounded monthly, whereas account B pays 2% APR compounded continuously. So we want to compare the growth rates to determine which account is more profitable. Now, what information do we know this time? Okay, so we know our interest rate, right? So we have an R value. What else do we know? Okay, the first situation is compounded monthly, right? And the other one's compounded how? Continuously, right? So that tells us then that we're going to need both of our formulas for compounded interest because one of them's monthly, we're going to have an end value, the other one's continuously, so that's going to be the P times E to the RT. Again, I'm going to write out my 2 formulas here. We'll talk about what we know and what we can put in there. But we do need both of those formulas this time. All right, so let's look at the first situation and think about what's given. So we said we know our interest rate. So that's going to be 1 plus. All right, so what's the R going to be for that account? Okay, good. So that one's 0.025. That's the one that's compounded monthly, which means our end value is going to be what? 12, just like the first problem. And then we're going to have 12 times something, right? So we don't have a t-value. We don't have a p-value this time. Okay, so I'm just putting in what we do know, and then we'll go back and talk about what to do with those values. Let's go to the other situation. So again, I don't have a p, but I know e is just e. What's my r value going to be for that situation? 0.02 this time, right? Because the one that's compounded continuously is just 2%. And again, I don't have a time, I don't have a principal. What I'm trying to do, though, is I'm trying to compare these two accounts to see which one would be more profitable. So as long as I choose the same amount of time to invest my money and I choose the same amount of money to invest, I could choose any values that I want to there. So how much money would you like to invest? 100, okay? That means I'm going to let my principal here be $100, and then over here, I'm going to make sure I use the exact same principal for that one. And again, you can choose any amount of principal you want here, just trying to decide which one's more profitable, and so it doesn't matter as long as you use the same amount. Now, what time? How long do you want to invest this time? One year, okay? So I'm going to put 1 here for t. That means over here, for this t value, I have to use the exact same amount of time. Okay, so we're investing the same amount of money for the same amount of time in both of those accounts, and now we want to see which one's more profitable. So all we got to do now is just simplify each one of those and see which one makes more money. So you can just put the whole thing in the calculator for the first one if you want to. Just be careful with your parentheses. And once you get that, let me know what you get. Okay, so $102.53. That looks good. So there's our amount for that one. And then what do we get when we do 100 times e to the 0.02? Okay, so $102.02. So the question is, which one of these accounts is more profitable? So which one's more profitable this time? The first one, right? So we would want to say account A is more profitable. So just make sure you're actually answering the question there, right? So the question is, it says compare the growth rates and then determine which account is more profitable. In this case, based off of what we got, account A is more profitable because we made more money there. Now, don't just assume that the one with the higher interest rate is always going to be the more profitable one, right? Because compounding continuously does make more money even at a lower interest rate, okay, than say like if we had 0.02 on the other. So just be real careful, because if that had been like 0.025 even, or sorry, 0.0225, and you were compounding for a longer period of time, it's possible that the continuously could eventually catch up even if the interest rate is lower. Okay. Any questions on that one? Okay. All right, so we want to solve each one of these algebraically. And so I know that a lot of calculators will do these, right? You can actually put a base 3 log of 1/27th in there, right? But I want to go through all the steps here to think about how we could rewrite this, how we could actually solve this by hand. So that's what I'm going to want to actually see here. So remember, the first thing I always did was I set it equal to some variable, right? So I'll just use x on this first one. So once we do that, how could we rewrite this problem? Okay, good. We could put it in exponential form. So what would the exponential form of that one look like? Okay, good. 3 to the x equals 1 over 27. All right, so now our goal is going to be to see if we can get the same base on both sides, because if we can, then we know those exponents are going to have to be equal. Is there a way that I could rewrite one of these sides or both of these sides to have the exact same base on both sides? Okay, so we could rewrite that as 27 to the negative 1. Right? I'm going to keep this as 3 to the x for now. Because remember, if you have a negative exponent, that would mean move it to the denominator. So I agree with that. I still don't have the same base on both sides yet, though. So is there a way I could take that 27 now and rewrite it with the same base we have on the other side? Good, right? So we could say, well, 27 is just 3 to the third power. So then this is going to become 3 to the negative 3 since we want to make it on the bottom. Any questions about how I got the same base on both sides there? Now, once we've done that, what's our x value going to have to be then? Good. So since our bases are the same, our exponents have to be equal. So our x has to be equal to negative 3. Therefore, the base 3 log of 1 over 27 is just equal to negative 3. Like I said, on this particular problem, on all the parts, that's what I'm going to be looking for is, can you rewrite it in exponential form? Can you get the same base on both sides? And then just set those exponents equal to each other. Any questions on that one now? So let's look at the next one. I'm going to use a different variable this time. So what's that equation going to look like once we switch it over to exponential form? Okay, good. So 2 to the y equals 0.25. Now, again, our goal is to see if we can get the exact same base on both sides here. So what could we try to make that happen, to get the same base on both sides? And one thing that might help here is to think of that decimal as a fraction so that it's similar to the first one we did. So 0.25 is the same as 1/4, right? So we know 2 to the y equals 1 over 4 now. So now it's kind of similar to the first problem we did. So how could we rewrite 1/4 to have the same base as the other side? Okay, so we could rewrite it as 4 to the negative 1. 2 to the y equals 4 to the negative 1. And now how could we rewrite a 4? Good. So this would become 2 to the y equals 2 to the negative 2, because 2 squared would give us 4, and we need to make it negative to move it to the denominator. And then once we've got the same base, now what do we know? Okay, good. So our y value in this case is going to be equal to that exponent, so y equals -2. Any question on that one? All right, let's look at part C. And so again, I'm just going to use a different variable here, so I'll call it z. So how are we going to rewrite this one in exponential form? Okay, so 1/3 to the z should be equal to 9. All right, so now we got to work on getting the same base on both sides. So what do you think we could try first? Okay, good. So we can rewrite this now as 3 to the -1 for the 1/3. And we can rewrite the other side as 3 squared to give us 9, right? We at least have a 3 as our base on both sides. And now because we have this -1 and this z here, we can multiply those together to give us 3 to the -z equals 3 squared. Any questions on how I got there? All right, and so then in this case, we would set the -z equal to 2. And then once we get rid of that negative, then z would be equal to -2 in this case. Good. Any questions on that one? All right, number 4. So number 4, we're just looking for domain, right? So this is where we have to start thinking about restrictions on the x values. So if we look at this one, I'm just going to start with the square root piece here. So what restrictions would I have on the square root? Okay, good. So we know everything inside the square root has to be greater than or equal to 0, right? We can't have any negatives in there. I'm going to take everything inside, the x minus 2 has to be greater than or equal to 0. Now, if we were to solve that, in this case, because it's just x to the first power, we can just add the 2 to both sides. So that tells us x has to be greater than or equal to positive 2. Okay, so there's one restriction on our domain. We also have a logarithm in this function, though, right? So what do we know about the stuff inside of a logarithm? Okay, all right, so 25 minus x squared can't be equal to 0. I agree. Is there anything else it can't be? Can't be negative either, right? So in this case, we're going to have 25 minus x squared is greater than 0, right? Because we can't have any negatives in there, but it also can't be equal to 0 because remember our logarithmic functions are always going to have an asymptote 0 unless we have transformations, right? Okay, so we know everything inside here has to be greater than 0. how are we going to solve that inequality? Okay, so you are going to get an x and plus or minus 5, right? Okay, so remember though, we're going to have to do our number line and our test point because we have a quadratic and it's an inequality. So what I'm going to do is I'm going to factor this into 5 minus x and 5 plus x. That's what's going to give us the plus and minus 5, right? Because then I can take each one of these and just set it equal to 0. Just to get those critical numbers that I'm going to put on my number line. So this one over here, if I add the x, that gives me x equals positive 5. And here, when I subtract the 5, that gives me x equals negative 5. Again, those are just the boundaries for my intervals now. And I've actually got a test in each interval to see where this thing is positive and where it's going to be negative. So what's a value I could choose to the left of negative 5? Negative 6 works. So I'm going to plug that back into my factor form up here. So if I do 5 minus a negative 6, what's that going to be? So when you subtract a negative 6, it actually becomes addition, right? So that's going to give us a positive. What about 5 plus negative 6? That one's going to be negative, and then a positive times a negative is going to give us what? Negative, right? So overall, everything in that region down there should be negative. What's a value I could choose between negative 5 and 5? 0 is good. Plug in 0. We have 5 minus 0. That can be positive or negative. Good. 5 plus 0 is going to be positive also. Positive times a positive is positive. Perfect. And then finally, something bigger than 5. 6 works. 5 minus 6 is going to be what? Negative. 5 plus 6 is going to be positive, and a negative times a positive is negative. Now, do we want positives or negatives this time? Good. We want this to be greater than 0, which means we only care about the positive values. That means I'm only looking at that one right there. So now I just got to put all this together. So I know for sure, based on the square root part, my x has to be greater than or equal to 2. But I also know now that I need to be somewhere between negative 5 and 5 because that's the only place log is going to be positive. So what's my overall domain going to look like this time then? Good. So we're starting at 2 because we know we need greater than or equal to 2, and we're going to include the 2 this time, so we need a bracket there. And then we're only going to go up to 5, and that 5 can't be included because it was strictly greater than, not greater than or equal to, so we're not going to include that endpoint. So the only values we have here is everything between 2 and 5, including the 2, but not including the 5. Any questions on that one now? All right. Same directions. We just want to find the domain this time. So how are we going to set this one up to find the domain? Okay, good. So we know everything inside the log has to be greater than 0, right? And we are going to factor, Kenneth, right? So let's go ahead and get the inequality set up. Then we can factor and solve for x. So we're going to have everything inside, x cubed minus x squared minus 2x. All of that stuff needs to be greater than 0. And again, that's for every single logarithm. If you're looking for a domain, just set everything inside the log greater than 0. Now we can factor. So how are we going to factor this? Good. So we can factor out the x because we have the common factor. That leaves us with x squared minus x minus 2. Now we look at what's left in those parentheses and see if we can factor that any further. Keep your x. So how's that x squared minus x minus 2 going to factor? Good. X minus 2 and x plus 1. So there's our factored form. Now that we've got that, what are we going to have to do next? Good. Set each of our factors equals 0. So we have x equals 0, we have x minus 2 equals 0, and we have x plus 1 equals 0. So the first factor there is solved. Don't need to do anything to that one. Second one here, when I add the 2, I should get x equals 2. And the last one, when I solve, I should get x equals negative 1. Okay. Now, once I've got those values, now I have to do what? Good. So we need to do our number line. We're going to choose our points. We're going to see where this thing is positive and negative. Okay, so our values here, the smallest one is negative 1. Then we have our 0. We have our 2. Okay, so let's think about something on the left-hand side here. So what value could we choose down there? Negative 2 works. Okay, so I'm going to plug that into my factored form. So if I do that, the x itself is going to be negative, right? Because that's negative 2. Negative 2 minus 2 is going to give us a negative. And then negative 2 plus 1 is also going to be negative. So if I have negative, 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 what's that going to be overall? Good. So an odd number of negatives should make the overall answer a negative there. What's something between negative 1 and 0? Okay, negative 1/2. So if I plug that in, my x itself is going to be negative because it's negative 1/2. Negative 1/2 minus 2 also going to be negative. But now negative 1/2 plus 1 is going to become positive. So I have a negative, and a positive, which would be what? Good. In that case, there's only 2 negatives. An even number of negatives should give us a positive overall. What's a value between 0 and 2? Works. 1 itself is positive, so the x is positive. 1 minus 2 will give us a negative, and then 1 plus 1 will be positive. So positive, positive would be negative overall. Good. And finally, I'll just go with 3 up here. Plug that in. 3 is positive. 3 minus 2 is positive. 3 plus 1 is positive. Everything's positive, so the overall answer is going to be positive. Perfect. Now, again, we have to ask ourselves, do we care about positives or negatives? We want the positives, right? Because we want this thing to be greater than 0. So I'm only looking at this one here and this one up here. So now if we write out our domain, what's that domain going to look like? Good. So we're going to go from -1 to 0. And then we have another interval, so we need our union. And then we're going to go from 2 to infinity. Notice here, everything's parentheses because we strictly want to be greater than 0, not greater than or equal to 0. So we're not going to include any of those endpoints this time. And that will be our final answer for the domain there. Questions on that one? All right, let's look at the next one. So we're going to evaluate this algebraically. So the first thing we're going to do is see if we can condense it and combine these, right? Then we'll rewrite it in exponential form and see if we can get an answer by finding the same base there. So how would we combine these first of all? So think about our properties of logs here. So we have a base 2 log, right? And we've got 3 of those. We know we have the same base. Okay, so good. So it's going to be base 2 log, and then we're going to divide 6 by 15. But then we can also do what? Okay, good. We can multiply now by the 20. So remember, subtraction becomes division when we combine these. The addition becomes multiplication when we combine them. So now we have a single logarithm with 6 divided by 15 times 20 on the inside. Now we just need to simplify what's inside there. So if we do 6 divided by 15, 20, what does that give us? Okay, so we get 8. So now we have a base 2 log of 8. So how are we going to solve that? Okay, good. So we know in this case that 2 to the 3rd power is equal to 8. And so this logarithm right here should just be equal to 3. And if you want to do the workout to the side, right, you could say, okay, I'm going to let my base 2 log of 8 be equal to some variable. That means 2 to the x equals 8. Get the same base on both sides. That becomes 2 to the 3rd. And now that I have the same base, that means my exponents have to be equal. So x has to be equal to 3 there. I don't need to see all that work, right? So if you just recognize 2 to the 3rd equals 8, therefore that base 2 log of 8 is equal to 3. This right here is the final answer. Any questions on that one now? All right, let's look at 7. So now we're going the other direction. So we've got a single log, and it's asking us to expand it, right? So this is going to be a base 10 log, common log. What's the first thing we could try to do here to start expanding? Okay, good. So let's get rid of the radical. So how could we rewrite the radical? Okay, good. So we could raise it to the 1/2 power instead. So I'm going to take everything inside there. So x squared plus 4 over x squared plus 1 times x cubed minus 7 squared. And all of that stuff is going to get raised to the 1/2 power now. Okay, so just remember, anytime you've got a square root, you can rewrite that as a 1/2 as your exponent. Okay, so now let's start applying some of those properties that we know about logarithms. So what's one thing that I could do here? Okay, so we can split up the division into subtraction. Good. What else can we do? Okay, we can move the 1/2 out to the front, right? And then we can also split up that multiplication in the denominator into addition, right? So we're gonna have to do all those things. First thing I'm gonna take care of though is this 1/2 goes with the entire logarithm. So I'm gonna move it to the front and rewrite this as 1/2 log of all of this other stuff, right? So x squared plus 4 over x squared plus 1 times x cubed minus 7 squared. So since that 1/2 goes with all of those terms, I go ahead and move that out front to begin with. Now let's start splitting up the division and the multiplication, right? So I'm going to keep my 1/2 here. And notice I'm going to put a bracket because that 1/2 is going to go with after this. So even though I'm splitting this into multiple logs, that 1/2 is going to go with every single one of them. We're going to have log of, what's going to go in that first log? Okay, good. So we take the x squared plus 4. Then we said the division here is going to become subtraction. So we're going to have minus common log. What's going to go in the second log? Remember, the subtraction here was what was division. So what am I dividing by? Okay, good. Right, so we can do the x squared plus 1. Now, if you want to, we can go ahead and split up the multiplication. Just make sure we insert another logarithm when we do that. So it's going to be plus log of x cubed minus 7 squared. Now, here's where we have to be really careful. That division that we changed to subtraction is going to apply to everything that's in the denominator. So I'm going to insert another set of parentheses around both of these logs here, just to make it clear, right, that subtraction now applies to both of these things that happen to be in the denominator, the x squared plus 1 and the x cubed minus 7 squared. And I'm going to close off my bracket there because the 1/2 is going to go with everything inside. So again, because we have multiple things in the denominator there, when I do that subtraction, change the division to subtraction, I have to make sure that everything in the denominator is grouped together, and that's why I need that extra set of parentheses there. Any questions on that step? Right. Is there anything else we can do here? Any of our properties we could apply? Good. So we still have a 2 in the exponent in that last logarithm, so we still move that to the front. So I'm going to keep my 1/2 out front here. We have log of x squared plus 4 minus log x squared plus 1. I'm going to bring the 2 out front of just that log, right? So plus 2 log of x cubed minus 7. And at that point, you could stop. If you want to distribute the negative to everything or distribute the 1/2 to everything, right, go right ahead. That's fine. Okay, but this answer that we have here now takes care of all of our properties. We've expanded as far as we possibly can. The only other thing you could do is possibly distribute and maybe simplify, but there's really nothing to combine. So if you leave it just like that, I'm fine. Any questions on that one? All right. We're not going to get through all of them, right? So I'm going to do as many as I can. See if we can get through 8 at least. So we're going to find the solution of this exponential equation. And it says we're going to give an exact value, right? So basically, don't just put it in the calculator, get a decimal. I actually want the exact value of this one. So if we're solving this and we have x's in our exponent, what are we going to have to do? So how do we solve an equation that has variables in the exponents? Good. So we need to take some kind of log on both sides. Natural log works. So let's take the natural log of 2 to the 3x plus 1. And we're going to take the natural log of 3 to the x minus 2. Again, it doesn't matter what type of log you use here, right? Natural log's fine, common log's fine, whatever log you want to use. Now, once we've done that, now what can we do? Move the exponents, right? So that entire 3x plus 1 is going to come out front. So I'm going to keep that group together. 3x plus 1 times the natural log of 2. And I'll bring the x minus 2 out front on the right-hand side. So that's x minus 2 times the natural log of 3. And now, just for time's sake, I'm just going to kind of work through the rest of this. The next thing you would want to do is distribute. So I'm going to take on the left-hand side the natural log of 2 and just distribute it to each of those terms. So when I do that, that gives me 3x natural log 2. And then when I distribute the natural log of 2 to the 1, that gives me plus natural log 2. Do the same thing on the right. I'm going to distribute the natural log of 3. So that's going to give me x natural log minus 2 natural log 3. Any questions on what I did there to get that line? Okay. So the next thing we're going to want to do is get all the x terms together and get everything else to the other side. So the way I'm going to do that is I'm going to subtract x natural log of 3 here, and I'm going to move it over here. But I'm also going to take this natural log of 2, and I'm going to subtract it to the other side. That way I get all the x terms on one side, and I get all the number terms that don't have x's on the other side. Now I'm left with 3x natural log 2 minus x natural log 3 equals -2 natural log 3 minus natural log 2. Now the reason for doing that is so that now I can factor out the x. Okay, so since I have an x in common on the left, I'm going to factor that out. That's going to leave me with 3 log 2 minus natural log 3. And then I still have my -2 natural log 3 minus natural log 2 on the right. Any questions about that step? All right. Finally, we just need to get x by itself. So I'm going to divide by everything that's in my parentheses there. And when I do that, I end up with -2 natural log 3 minus natural log 2 all over everything in the parentheses. So 3 natural log 2 minus natural log 3. That is an exact value. That's what I'm going to be looking for in this case, right? So again, don't try to put any of this in the calculator and round off your decimals or anything like that. Whenever it says exact value, make sure you keep all those logs in your final answer. Now, we are out of time. If you have questions on any of the other ones, this afternoon or between now and when the test is due, just let me know, and I can set up a time, meet with you, work through those. But at least look at my solutions to the practice test, right? Because they are, all the work is there. But if you do have any questions about how I got anything, just reach out and let me know. Okay. Any last minute questions before we go today? All right. If not, have a good afternoon, and I will see you tomorrow. Yeah, Kenneth, I'll set up that meeting for you.